graphical representation of Boyle's law. Of Boyle's law. Now, there are two ways you are going to plot a graph to represent Boyle's law. The first one you need is to draw a vertical line and a horizontal line. This is your volume in cm3. This is your inverse of pressure in Newton meter. Your slope is going to start from the origin. Okay? But in exam, you may see a question like this where they ask you which of the following graph best represent Boyle's law. They will draw something like this. They will draw something like this. They will draw something like this. See? Like this. And they will draw something like this. Like this. That does not mean that the answer is not there. Okay? So there's another way you can plot a graph to present Boyle's law. Guys, if you are plotting volume, directly proportional to pressure, like here, volume is cm cubed, directly proportional to pressure in Newton. Your slope, if you are plotting volume against the inverse of pressure, your slope will start from the origin. But if you are plotting volume against directly proportional to pressure, your slope will be a curve like this. That is for that slope. Then we go to the next one called Chance law. The next Chance law is Chance law. What is Chance law? Okay, the law says that the volume of a given mass of a gas is directly proportional to its temperature in Kelvin. To its temperature in Kelvin at a constant pressure. Now, we can use graphical representation to prove this law. We can use mathematics to prove this law. That is, mathematically, the law says that volume is directly proportional to temperature. And in mathematics, you want to know this and you add a constant. That means that volume is equal to kT. So, if you want to make K draw a formula, that would be that V over T is equals to K. So, if V over T is equals to K, it means that when you have V1, T1, you also have V2, T2. This is how Chance law was proved. Then, we go to the graphical representation of Chance law. In exam, those of you writing ahead that are watching me online on Facebook, YouTube, and Instagram, so you might ask me why to use a graph to represent Chance law. So, graphical representation of Chance law. If you are plotting a graph to represent Chance law, it's not going to be like that of the Boyle's law, because here you are plotting volume that doesn't proportional to temperature, not like the Boyle's law where you're plotting volume inverse proportional to pressure. So here you're going to draw a line like this, another line like this. Then here is your volume in cm cubed. Here is your temperature in degrees Celsius. Then your slope will not start from the origin. Your slope will start from here and have the zigzag line here. Then here is minus 273 Kelvin. But you should also note that this is your 0 degrees centigrade. That means that note the volume of any gas at 0 degrees Celsius is minus 273 Kelvin. So we are going to talk about temperature conversion. How we talk about temperature conversion? Because in Chance law, the temperature must be in Kelvin. So when we talk about temperature conversion, we're talking about how to convert from degrees Celsius to Kelvin. Now, in mathematics, if you want to convert from degrees Celsius to Kelvin, you're going to add 273. While if you are converting from Kelvin to degrees Celsius, you're going to do minus 273. For example, example 1. Convert to Kelvin. A, 10 degrees Celsius. B, 20 degrees Celsius. C, 30 degrees Celsius. What are you going to do here? Solution. You say, number 1, 10 degrees Celsius will be 10 plus 273, which will give you 283 Kelvin. While the third one is 20 degrees Celsius will be 20 plus 273, which will give you 293 Kelvin. And the next one is that 30 degrees Celsius will be 30 plus 273 equals to 303 Kelvin. Okay, this one is how to convert from Kelvin to degrees Celsius. But from how to convert from degrees Celsius, sorry, this is one is how to convert from degrees Celsius. Okay, convert to Kelvin, yeah, that is converting from degrees Celsius to Kelvin. But another example is that you can be asked, example 2, convert to degree Celsius. If you want to convert to degree Celsius, for example, we give you maybe 283 Kelvin, B 293 Kelvin, C 303 Kelvin. What do we do? Solution. You will now see that A is 283 will be 283 minus 273 equals to 10 degrees Celsius. B is 293 will be 293 minus 273 will give you 20 degrees Celsius. C will be 303 will be equals to 303 minus 273 will give you 30 degrees Celsius.